Children, it is a continuation of the exercise of the chapter motion. Now you take the question number 8. Here there is a graph. The graph is speed time graph for a car, and the graph is shown in the figure. That is the figure 8.12 of your textbook question. Find how far does the car travel in the first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during the period. Which part of the graph represents uniform motion of the car here? And how far does the car travel in the first 4 seconds? Here time is represented on the x-axis, 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, and here the time 4 second time is here, and distance traveled in 4 second is you take the first question answer. Distance traveled in 4 seconds, that is area under speed time graph, that is what area under speed time graph. So the distance traveled in 4 seconds is equals to what? That is area under the speed time graph. Here that is equals to average speed into time. It is average speed into time. Here average speed is nothing but speed. Here you take the speed at 0 second and speed at 4 second. Speed at 0 second is here 0 only. See here it is 0. Speed at 0 second is 0 and speed at 4 second. Average speed means that is average of the speed at 0 second and 4 second. That becomes here, that is final speed plus initial speed by 2. Average speed is nothing but final speed, or you take initial speed plus final speed by 2. That is the average speed into time. Time is here 4 seconds, you write. So it is initial speed is, that is 0, and the final speed is, here it is, the speed at 4 seconds is 6 Newton and speed at 0 second is 0. So it is 0 plus 6 by 2 into 4, it is 4 second. It becomes 6 by 2 into 4 second. Then 6 by 2 means here, that is average speed means 3 ms to the power of minus 1 into 4s. So it becomes 12 meter. So the distance traveled in 4 seconds is 12 meter. That is speed into time. That is nothing but average speed into time. Average speed is nothing but u plus v by 2. That is the initial speed plus final speed by 2. So speed at 0 is initial speed. Speed at 4 second is final speed. That is speed at 0 second is 0. See the graph here. Speed at 0 second is 0. Speed at 4 second is 6 here. So average speed is 0 plus 6 by 2, and that is time is 4s. So it is 6 by 2 into 4s, that is 3 ms to the power of minus 1 into 4s, because the speed is measured in terms of ms to the power of minus 1. Therefore you write distance traveled in 4 seconds is equals to 12 meter. Next here, which part of the graph represent uniform motion of the car? Which part of the graph represents uniform motion of the car, you know that for uniform motion, the speed time graph is a straight line. Here, the straight line starts from, here you can make out the straight line starts from, here it is. So, you can say that the straight part of the curve parallel to the x-axis, that is time axis, represent the uniform motion of the car. Which part of the graph means here? This is the straight line part. So you take second question B. For uniform motion, what is the nature of the graph here? The nature of the speed time graph is straight line, parallel to time axis. So here the straight part of the curve is there here. See here there is a straight part of the curve from here to here, to here. So this part represents the uniform motion of the car. So you take, therefore, what is that? The straight part of the curve. Straight part of the curve parallel to the time axis. Parallel to the time axis represent the uniform motion of the car. Represent the uniform motion of the car. So this is the answer for the question B of that 8th question. So you got the answer for A and B. Next, let us take the next question, that is the 9th question. What is that question? State which of the following situations are possible and give an example for each of these. An object with a constant acceleration but with zero velocity, one situation, that is the situation A. Second situation, that is B. An object moving in a certain direction with an acceleration in the perpendicular direction. So the first case, you know that when an object is thrown vertically upward, it reaches to some height, and at that height the velocity will become 0, but it will be under the influence of the constant acceleration, that is acceleration due to gravity. So what is the situation you can give here? The example of situation of an object with a constant acceleration but with zero velocity is when the object is thrown vertically upward. When it reaches highest point, its velocity is 0, but it has constant acceleration, that is due to gravity. Probably the acceleration must be equals to 9.8 ms to the power of -2, which is the average value of the acceleration due to gravity. So you write the answer for the first question A. Answer for the first question A, that is situation. Example for the situation of an object with a constant acceleration but with zero velocity. So you take example of the situation to show an object with a constant acceleration but with zero velocity. But with zero velocity, that is, answer is here. When an object is thrown vertically upward, when an object is thrown vertically upward, then at highest point its velocity is zero. Its velocity is zero, but it has constant acceleration. Acceleration that is approximately equals to 9.8 ms to the power of -8, which is due to gravity. That is the acceleration due to gravity. Acceleration due to gravity. And second one, B, an object moving in a certain direction with an acceleration in the perpendicular direction. Here you can give the example of the movement of the aeroplane. An aeroplane flies in horizontal direction, but the acceleration due to gravity acts on it in vertically downward direction, that is along the direction perpendicular to the direction of motion. So you can give the example of the flight, that is aeroplane moving in horizontal direction. So you take, that is B, example of situation of an object moving in a certain direction, with an acceleration in the perpendicular direction. Here the answer is, here the situation is that an aeroplane flies in horizontal direction but the acceleration due to gravity acts on it in vertically downward direction that is along the direction perpendicular to the direction of the motion. Perpendicular to the direction of the motion. This is the example for the second situation. Now the 10th question. An artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the earth. So here you know that it is a example for the uniform circular motion, and the radius of the orbit, artificially a satellite is moving in a circular orbit of radius 42,250 means the radius of the orbit is, that is r is equals to 42,250 km, and distance covered in one revolution means that is the perimeter of that orbit, that is equals to 2 pi r, that is the distance covered is equals to here 2 pi r. So you first you find the circumference of the orbit here, that is nothing but the distance covered by the satellite, and also here it is given that time taken to revolve around the earth, that is time taken to complete one round in that orbit is given, that is 24 hours. And with the help of the speed formula, that is speed is equals to distance by time, we will get the speed here. So here first you write that you take r is equals to here, that is 42,250 km, and distance covered in one revolution is equals to distance covered in one revolution is equals to, that you can take d or s, that is equals to what here, that is 2 pi r, that is 2 pi r. So s is equals to, or 2 pi r is equals to, you write that is 2 into pi is 22 by 7, r is here 42,250. So it becomes, you know that here if you multiply this you will get, that is 2 into 22 into 42 into 250, multiply that you will get, that is 26. So that becomes 2,65,571.43 km. You calculate it and verify here. Next, here what you have to do, we have to find the speed of the satellite. Now here time taken to complete one round is given. So what is time taken here, that is t is equals to 24 hours. So you write the formula for speed, that is speed is equals to distance by time, distance by time, that is equals to, the distance is 2,65,571.43 kilometer. Time taken is 24 hours. So it becomes, if you divide it, you will get 11,065.48 kilometer per hour. You divide 26,557.43 by 24, you will get this value here. Therefore, the speed of the satellite is, the speed of the satellite. Therefore, speed of the satellite is equals to 11,665.48 kilometer per hour.